This is our last example from our right triangle practice. We've been trying to solve for x in each of the triangles that we've been looking at. So in our final example here, I have a right angle triangle. It has a side of 61 and 45, and this time we're trying to solve for angle x. So when I'm trying to choose a method, if I only have side lengths and only want to find side lengths, I would use Pythagorean theorem. So to use Pythagorean theorem, you need to have two sides that you know and be looking for the third side. If you are given an angle or are trying to solve for an angle, that's when you want to use the sine, cosine, or tangent ratios. So in this question, I wasn't given an angle, but I am trying to find that angle, which is why I would use either sine, cos, or tan. So the first thing we should do is label our diagram. So across from the 90-degree angle, that longest side is our hypotenuse. Across from the angle in the question that we are trying to solve for, that's our opposite. And then the one beside the angle is the adjacent. Now I like to look and see if there's a side that we don't know anything about, and in that case that would be the opposite. It doesn't have any markings or things labeled that we want to try to find. So I'm going to focus on the hypotenuse and the adjacent. So to help me figure out a ratio, I like to use the word SOHCAHTOA. So I have H and A. So I'm looking for one of these that has an H and an A, which would be our cosine ratio. So I'm going to do that cosine of angle A is A adjacent over H hypotenuse. So cosine of, I don't actually know the angle this time, it's just an x. So cosine of x is adjacent 45 over hypotenuse 61. Now from here, the last two questions that we did, our next step was to cross multiply. But this question's a little different because the x is not part of the fraction. The x is with the cosine. And our goal in all three of the examples that we've done so far is to get x by itself so that I know what it equals. So here, I need to find a way to get the x by itself. So cross multiplying is not going to make that any easier. What I need to do is find a way to get rid of the cosine. How do I get rid of the cosine? I do its opposite operation, which is called the inverse cosine. It looks like a cosine with a little exponent of -1, and I'm going to do the inverse cosine of both sides. So this is going to cancel out that cosine to leave me with just x. And then on this side, I'm going to have the inverse cosine of 45 over 61. You'll notice I put the 45 over 61 in a bracket to show that we're doing the inverse cosine of the whole thing. Now, if you have a calculator where you see what you type in on the screen, you're just going to do shift cos or second cos, depending on what color or what button you have. I have a second button and it's orange and it matches up with the inverse cosine above my cosine button. And then you would do bracket 45 divided by 61 equals. But because I don't see what I type in on the screen, I have to start with the bracket. So I'm going to do 45 divided by 61, and then I want to hit equals, and then I'm going to do second and cos. And I get that x is 42.46. The next number is a 3, so it's actually going to stay 42.46. So it's 42.46. Now, the units in this question were meters, but we are trying to find an angle, and angles are measured in degrees. So it's going to be 42.46 degrees. And those are all the examples that we are going to do together of right triangle practice.